All right, I think I'm going to get going. Hello, everyone. I am delighted to be here and share with you a new approach to doing FHIR analytics. My name is Patrick Jamieson. I'm a product manager for Iris for Health, and I lead a team of very talented developers, engineers, and other managers that really should be given the full credit for this presentation. So here's my very brief agenda. We're going to talk a little bit about FHIR analytics and why it's important, and how this new tool called the FHIR SQL Builder makes analytics possible to do on FHIR data. At the end of this, I hope this will extend your knowledge of how you could approach doing analytics with FHIR and how you could create a custom SQL schema from your FHIR repository. So what are the use cases for FHIR analytics? Well, they're very broad and basically encompass some of the same analytics use cases for healthcare in general. And you could see this on this slide. I won't really go into these in detail. So you may be asking yourself, well, what is the problem? Why can't I just do this directly? The answer is that FHIR is a complex directed graph. It is non-relational. And so we have to figure out ways in which we could flatten it or transform it into a SQL schema. So here's just a quick example of a few FHIR resources. You could see there are directed links from resources to resource, so observation to patient, patient to practitioner, practitioner to organization. That may look simple, but an actual graph of a patient's data will embrace many more resources, conditions, observations, medications, etc. So it's going to be real complex in the majority of use cases. If you look at particular resources, what you see is that FHIR resources form a tree. Those trees contain elements, and those elements contain other objects. And in some cases, they include arrays of objects. None of this is bad by itself, but this is very non-relational. And you could see over on the right-hand side a JSON representation of this. If we look at that JSON representation, we see nested JSON structures, again, making it more difficult to do analytics. So what are your options then if you want to do analytics with relational tools with FHIR data? Really, you have three major ways you can go about this. You could use a language called SQL on FHIR, and I'll show you an expression of that in a second. You could extract the FHIR data with FHIRPath and then populate a schema that might be used in a business intelligence tool. And then you have a third alternative that I'm going to talk about, which is projecting that FHIR data. So I promised you I'd show you an expression of SQL on FHIR. This uses special operators that are not part of ANSI SQL. So for example, you'll see things that resemble FHIRPath expressions using the dot syntax. And then you have other operators that can take objects and unnest them so you can make queries. So this is an approach, and this will work, but again, your data analysts are probably not terribly familiar with it. So why did we create the FHIR SQL Builder? We wanted to create a sophisticated projection tool that would help developers create custom SQL schemas for various use cases where the data lived in their FHIR repository but was transformed to FHIR data in relational tables so that they could use ANSI SQL or any BI tool. I won't go into this in any detail, but the InterSystems Iris database is what makes this possible. Why? It's because it's multi-model, so it has very efficient multi-dimensional arrays, and it supports a number of data storage paradigms that make it easy or relatively easy to expose FHIR as a relational projection. So here were our top design goals. We wanted a data steward to be firmly in control of creating SQL schemas, as many as needed for different use cases. We wanted to have an easy-to-use GUI so that you didn't have to learn FHIR. And we also wanted to enable multiple schemas to be created, because I don't think there is a universal data schema in healthcare for different use cases. So what are the steps for making the best SQL projection? We think we need to empower users first to understand what's in their FHIR repository, create custom mappings between elements and columns or other subtables, and then have the ability to index those columns in related tables. So let me show you the steps to do this. We first analyze the FHIR repository and display resource and element counts for selection in a transformation specification. We obtain the user selection, and then we generate these SQL projections under the hood. And the nice thing is you could then modify them as you make changes to your schema. And again, the key to all of this, to do it performantly, is our underlying data architecture, IRIS, which is a multi-model database. So with that, I'm going to show you a demo. This is pre-release functionality. We'll have this in the next quarter, but I think you're going to enjoy it. So here, I'm starting off with the main page of the SQL Builder, and I'm going to log in with my username and password. This is just part of logging in with IRIS, so I'm logging in with credentials you normally wouldn't use, system and the admin password. So I'm logging in, and you see a blank slate here, a blank opening page, because I've done no analyses, no transform specs, and no projections. So I need to create a new analysis. So I'm going to connect to a FHIR repository. So I'm going to hit the New button. I'm going to name the repository anything I want. I'm going to name it Demo in this case. And then I'm going to use the host name. This is localhost on my machine, and the port for where the repository lives. Then I need to enter some credentials. I'm going to use the administrator credentials, which obviously you wouldn't use in a normal system. But I'm going to put in my username and password here so I could access that repository and be able to do this analysis. Then, because I've set this all up, I can just simply select the FHIR endpoint. It knows what endpoints exist in the system. I'm going to just go ahead and save that. And I now could select how many records I want to analyze. Now, this is a pretty small repository, so I'm going to analyze 100% of the records. In a real large repository, you'd probably only do a sample of records, or if you really wanted to analyze every single record in your repository, you'd probably run this as a long-running process overnight. We have a way to set up a job so that you could do this. So we're about 30% of the way there. I think I'm going to speed this up a little bit. Okay, we're at 42%, and we'll see. Okay, so we analyzed 100%. Now I'm going to go ahead and build a transformation specification. Again, I'm going to click on the New button, and I'm going to go with the a name. I have to select some name. I'm going to just call this transform number 1. And I'm going to reference the analysis that I just did. Okay, so I'm going to use that analysis to create my transform spec. Now on the left side, you see all the resources in the repository and their counts. So you see we have 74 allergy intolerance resources, 27 device resources, and 115 patients. We could then expand this to look at the elements for that particular resource. So for metadata, we would expect to see 115 count of the last updated element. And you could see this would be the FHIR path expression. I'm not going to project that with that name because I don't think most analysts would be familiar with it. And I'm going to go ahead and index that. So that's all you need to do to add this to your SQL schema. So let's take a look at some other ones because some of them are a little more complicated. Identifier, for example, has repetitions because it's an array. So we want to capture the system and value for the identifier, but we're going to put a filter constraint on this. Why? Because there's an array of identifiers. Now we could capture them all in a subtable if we want, but I'm going to collect and set a filter on a specific coding system. Under the hood, what's happening is we are using FHIR path to constrain that in our projection. So let's go ahead and select a few more elements, and I could take a look at marital status. And again, we could look at things like the coding or display. Here I'm going to just select display. And again, you could transform the names of any of these columns if you want. Just for the sake of time, I won't do that here. Let's take a look at extensions. This is something that is frequently common, especially with US Core. I'm going to take a look at patient birthplace. So I'm going to select that, and then I'm going to navigate down to the city and going to include this in the projection, but I could also display a bar graph of what cities are in this repository so I could get a feel for what my data looks like. You certainly don't need to do this. This is just an optional step, but I'm going to just shorten this to patient birthplace city, and I'm going to do that again for state. And again, I'm going to I think shorten this. You could see the states. This is synthetic data, so most of the patients are in Massachusetts. And I'm going to again shorten this up, and we'll just call this patient birthplace state. All right, now we can make a projection. We're done with the transform, so we'll create a new projection of this data. And all the work is being done under the hood. So I select the FHIR repository. Obviously, I've saved the credentials. I put in the transform spec I want to use because you could have more than one. And I'm going to create a package name. And this package name I'm just going to call SQL1, and I'm going to launch that projection. So at this stage, we could then do queries on the data. So I'm going to hit the link here and log in again to Iris. And at this stage, I'm going to filter by that package name. And I'm going to look at the tables. I only created one. And you could see the columns here that we have just created now are all reflected in the query. So if we go ahead and execute this, you'll see that we have now projected all of that data, and we're essentially you could it's flattened out. Now, of course, we could go back and revise this. I'm going to show one more example. This is from a repository I built earlier. I'm going to take a different transform spec. What I wanted to show you is that you could combine data from patient and observation. So again, I've created a special projection, and I'm going to then paste in here a query I developed to basically show an aggregate of this data. And now you could see the number of observations by city. So again, this is highly performant. If you index the correct keys, you should be able to get that data very, very rapidly. All right, so to end off here, I want to just leave you with a few thoughts. First, there's some very good videos that we've made that maybe go into maybe a slightly more detail on this, that you can copy these links and view I think you'd find them pretty interesting. It goes over kind of what I've talked about. And then my contact information. So feel free to contact me. I'd be happy to answer any of your questions. Thanks.
Does anyone here in Cleveland have a question? I do have one virtual question.
Okay.
Let me read the virtual one first as I walk over there. So, is the projection always one table per FHIR type, or is it possible to create one table by joining two or more FHIR types, e.g. patient plus observation?
No, yes. The projections as we built into this GUI are only one table per FHIR resource. Now you could join those tables in a SQL query. And, you know, if there was really a reason to do it, I guess we could, in theory, engineer something like you described, but there hasn't been any use case for that.
Thanks. I was just wondering, like, the practical workflow, I would imagine that you would be working hand in hand with a data analytics person as you're developing the schema. Like, so
Sure.
Are you bouncing back and, or is it two people? One person who's a FHIR expert. Practically speaking, how does this kind of work?
We envision that the data steward is more of the FHIR expert, and the data analyst is really someone who works at a hospital, let's say, and just understands data analytics from a pure relational side. Now, obviously, over time, those roles might shift a little bit as data analysts get more familiar with FHIR. But right now, we would see that those two people would work hand in glove and tailor schemas for their different use cases.
I have another virtual question. I think the projection is useful to avoid moving data, but for greenfield projects, the same idea could be used to store the data.
I'm not quite sure. You mean the idea of going from a relational view to data in the FHIR repository. Unfortunately, that doesn't work. We do not have the ability. This is a read-only view of the repository. It is not a read-write view, so you can't go in the reverse direction. And you could see why, because effectively those column names could be anything. How would you know what they map to in FHIR? Yes. Oh, there's somebody in the back.
Do we have a question?
Hello.
Hi.
We've been looking at something kind of similar, and I'm curious if you see like the first step of this, the nested structures of resources and tables as a standard for like that first step out of FHIR.
Well, that's just the FHIR standard. I mean, FHIR has nested data types and has arrays. Mm-hmm. That is something that anyone who uses FHIR knows or experiences. The problem is that FHIR was really designed, for transactional work. It's a kind of a transactional database, not an analytic database.
Yeah. Oh, yeah.
And so the challenge is, you can make it analytic, but you're going to have to use some special methods. There's no easy way to get around that. And I think the best way is projections. Why? Because A, it's real time, and second, it doesn't duplicate the data. If you have a large FHIR repository, that could be a real problem.
Yeah, for sure. Have you seen any need for like default flattening?
Oh, yeah. That's an interesting thing, kind of, in quote, the starter pack. Yeah. My boss has gotten after me many times on this, and I said, it's coming. But no, we do not have a starter pack as of today.
So we are at time, but I do want to let you know there are two more questions in the virtual Q&A. Patrick, if you could log into
Sure.
HUBA and address those. The questions in the virtual Q&A do stick around after the the whole event is over. And if anybody here in the face-to-face session has additional questions, you too can enter them in the Q&A. So
Be happy to take them. Yep.